Welcome to Unit 3 Test Review Part 2. Yes, the Empire Strikes Back of test reviews for this unit, which means it's going to be better than Part 1. We're going to mainly focus on greater division, since that's pretty much what we've been plugging away at. I'm going to do expanded notation first, and then I'm going to touch on the shortcut method here. And we're going to start with an example problem from the test review. This is number 14. Number 14, the dividend. Let me put a little, hey, it's number 14. Put a circle around it so I know it's not part of my problem. We've got a dividend of 2,203 and a divisor of 4, so I need to figure out how many groups of 4 can I get out of this big old number. Well, first I'm going to think to myself, can I get any thousands of groups of 4? And in my thinky brain, I start by thinking, well, 1,000 groups of 4 would be 4,000. Well, I don't have 4,000, so I'm just going to stop thinking about that in my thinky brain. I might even put a little X here, because I'm like that. And I'm going to put a number there. Bad plan. So then I need to go to my hundreds. And I bet it's going to be a lot of hundreds of groups of 4, because I do have a thousands dividend. And right away I'm realizing, well, 100 groups of 4 is only 400. I feel like I'm going to have to jump up. So I'm going to jump up and just start thinking about halfway through my little facts list. 500 groups of 4 would be 2,000. 5 times 4 is 20, times 100 is 2,000. 600 groups of 4 would be 2,400. I don't have 2,400, so 500 groups of 4 is the largest grouping I can make in the hundreds, which means that I've grouped 2,000 of my 2,203. Hooray for me! So I'm going to stop thinking about that, and I'm just going to figure out, okay, what's left of my dividend? Still got to group 203. Well, then I'm going to be thinking in terms of, tens of groups of 4. 40, 20 times 4 would be 80, 30 times 4 is 120, 40 times 4 is 160, 50 times 4 is 200. Aha! 50 times 4 is 200. I'm definitely not going to get to 60 times 4 because that's 240. So I can get another 50 groups of 4 out of this, which takes another 200 out of my dividend, and that leaves me with 3 in my dividend. Well, I can't get a group of 4 out of 3. So I think we all know what that means. When we end up with, when we've divided everything from the dividend and it ends up being less than the divisor, it's got to be a remainder. So I made 500 groups of 4. I made 50 groups of 4 together. That's 550 groups of 4. And I have this remainder of 3 that's just kind of hanging out there on the side. So the shortcut method. Well, I've already started it up, because the truth is the first parts, if you are fluent in the shortcut method, these first parts are not too hard for you. You're probably saying things to yourself, well, like 4 doesn't go into 2, but it goes into 22 5 times, and 5 times 4 is 20, and that's going to leave me with 2, and then I'm going to bring down mysteriously the 0 and the 3, and then I've got 203, which honestly isn't that weird. If you look back at the expanded notation method, we had 203 at one point, and again, I'm going to say to myself, well, 4 can go into 25 times, and I can take that 20 away, and I still end up with that remainder of 3. But here's the weird part. Look at that quotient. It looks like the quotient is 55. But in the expanded notation version, it was 550. It still is here, because remember, we've got the ones place just hanging there empty. And the ones place doesn't disappear. And that 5's in the hundreds place. The other 5's in the tens place, so they've got to be a 500 plus 50. So again, when we do shortcut, we've got to think in terms of those placeholders. And we need to remember, if there's a remainder, that's got to be tacked on as well. Watch out for those zeros, you people who love the shortcut method. Okay. One more kind of naked numbers greater division problem. Here we have a dividend, problem 16 from our test review. 7,534. We're going to make groups of 5. I love groups of 5 because 5s are like really easy for me to do in my head. Speaking of that, I'm going to make a little brain over here on the side to think in. Now, can I get any thousands of groups of 5 out? Well, immediately I'm thinking 1,000 times 5 is 5,000. 2,000 times 5 is 10,000. So I can't go as high as 2,000, but I can definitely pull 1,000 groups of 5 out of this 7,000 and something. Which means that I've already grouped 5,000 of this number. Oh man, that was easy. I love it when it starts out nice and smooth. That still leaves me with 2,534 that I've got to put into groups of 5. And I can't do any more thousands of groups of 5, so now I'm thinking in terms of hundreds of groups of 5. And I can start out, well, 100 times 5 is 500, 200 times 5 is 1,000, 300 times 5 is 1,500, 400 times 5 is 2,000. Ooh, I'm getting close. 500 times 5 is 2,500. Oh, I'm not going to do any better than 500 times 5. Because I'm thinking to myself, well, 600 times 5 is going to be 3,000. And I do not have 3,000 to group. But I do have 500 groups of 5. Or 2,000 to group. Hooray! That still leaves me... Ooh, I may not have left enough room on my page. I'm going to have to improvise here. That still leaves me with 534. No. I'm sorry. Ignore me. I am a silly goose because, of course, 500 times 5, just like I said before, is 2,500. Duh. That leaves me with 34. Plenty of room. Now I'm in the zone. How many 5s in 34? I'm back to 3rd grade math. Woo woo! That's 6. There are 6 5s in 34. 6 5s is 30. And that leaves me, and put a little arrow over here, with 4 just hanging out there. I can't make a group of 5 out of 4. That must be my remainder. Let me put this all together. I made 1,000 groups of 5, and I made 500 groups of 5, and I made 6 groups of 5. Now, if I add those together, that's 1,506, and then I have my remainder of 4, looking kind of funky up there in the corner and cut off, but you can see it at the bottom. Remember, shortcutters, this is where things could get kind of funky for you. Really make sure you're lining everything up by place value if you're doing that shortcut stuff. Because that's all got to be, you got to keep that all straight somehow. And, you know, if I wanted to, we haven't done this yet, just want to give everybody a little reminder, we can always use the inverse operation to check on some things. So what if we wanted to check to see if we are on the right track here? Well, then we would multiply 1,506 times 5. And here I'll do a little shortcut multiplication. And don't worry if you're thinking, no, we did it wrong. No, we didn't. We just have to add that remainder quotient times the divisor plus the remainder. If it equals the dividend, and it does, yes it does, then you have happiness because you've mathematically proven your work. Alright, last but not least, let's talk about problem solving. So we have this kid and her dad, they're making these muffins. They've made 256 banana muffins and 298 chocolate chip muffins, tasty good. And they need to put the muffins into boxes of 6. What we have to figure out is what's the greatest number of boxes that they can fill with muffins. I think the word that I jumped out at me when I was reading this question was that the boxes have to be full. No partial boxes if we're saying they're going to be filled. Well, first off, I can kind of go a couple of different ways with this, but I think that the most efficient way is to think, well, okay, I know if I'm going to be figuring out how many groups of 6 I'm going to have to divide, but what am I going to divide? Well, the number of muffins. So my first step question is, well, how many muffins do I have? I know I've got 256 of one kind, and I know I've got 298 of the other kind. What I don't know yet is how many muffins that is total. Let's find out. Oops, that's a funky 4. Oh, I feel like after my crazy mistake earlier, I need to fix that. All right, 8, 9, 10, 11, 12, 13, 14. Going to carry the 1. I do groups below, and 15 groups below again. So it looks like there are 554 muffins total, and I need to figure out how many boxes of 6, or groups of 6, right? If I need to know how many groups, I have to divide. I'm going to use expanded notation. Probably not a surprise, because that's my thing that I like. Can I get any hundreds of groups of 6 out? No, because 100 groups of 6 would be 600. That will not work. Then I'm going to say to myself, can I get any tens of groups of 6 out? I think I'll put my brain up here. Well, 10 times 6 is 60, and 20 times 6 is 120, and 30 times 6 is 180, and 40 times 6 is 240, and 50 times 6 is 300, and 60 times 6 is 360, and 70 times 6 is 420, and 80 times 6 is 480. Wow, this is going. Well, 90 times 6, this makes sense to me. 9 times 6 is 54. So 9 times 60 is going to be 540. So it's definitely going to be 90 groups of 6. I should have been using my math sense from the beginning instead of counting all up like that. But we got there. And we managed to group most of the muffins. Now, how many 6s are in 12? Well, I can get 2 6s out of that, so I can knock out 12 more into groups. And that leaves me with 2 that I haven't been able to deal with. So I have 92, remainder 2. But that is not the answer to this question. It says, what is the greatest number of boxes that can be filled with muffins? Well, I look at my quotient and I realize I can fill 92 boxes full. Then I'm going to have 2 extra. Maybe the kid and her dad can eat them. I don't know. But they can't fill boxes. So the answer is, what's the greatest number of boxes would be 92 boxes. Sometimes the remainder is what we need to look at. In this case, the remainder is a number that we have to kind of ignore because we're looking at a full groups, not leftovers. Keep in mind that, notice those words like greatest number, filled. They're going to clue you in that you may have a remainder, but the remainder's probably not going to fit in. Okay, man, I know, lots of video, lots of thinking. Review your work. Remember those vocabulary words: dividend, divisor, quotient, remainder. You could totally do this. You are on fire with this stuff. See ya later.